I want you to think of generative AI kind of like a new CPU. Now, what do we do with CPUs that are in our laptops and other things? We give them information and we give them instructions, and then we ask them to go and perform tasks for us. Now, if you think about all the components of the prompt that we talked about, information is one that we haven't spent a lot of time on so far. We've talked a lot about the other components of a prompt, but information is critical. And when we start thinking about generative AI as something that we go and use to process information, then we have to think about the quality and how do we get the information into the system. And this is where retrieval augmented generation comes in. And this is a fancy word for really how do we get the right information into the system so that it can go and process it and help us solve problems or perform tasks. So what is retrieval augmented generation? Well, let's start by looking at the fundamental problem that we have to deal with when we don't give the system the information that we need. So a lot of people go and they use generative AI and large language models in particular like their internet search, as if they already have all the information you could ever need, and therefore we don't need to give them information. And this is incorrect. So let's start off by showing this. So BMX and kids BMX racing is a fairly niche sport, and it's something I don't think that GPT-4 has information on. I don't think it knows who won certain contests last year. Now, it may be able to go figure it out, but I'm going to give you an example of what we're trying to solve for. So my son races BMX bikes. He was the Tennessee 9 Intermediate state champion last year. So I'm going to go in and I'm going to ask GPT-4. I'm going to say, who was the 2023 Tennessee 9 Intermediate BMX state champion? And it comes back and it says the 2023 Tennessee 9 Intermediate BMX state champion was Hutch Griffith. Well, that's not true. That's hallucination. And I know because my son was the one who actually won it. And my son's name is not Hutch Griffith. But I also know because I know most of the kids that are racing in this sport because it's a fairly small sport. And so I know that I don't think there's a Hutch Griffith in Tennessee. Now, maybe there is, but I don't think he's 9 Intermediate because I would remember my son racing him. So this is hallucination at work. This is when we don't give it the information and it tries to guess on the quiz. It tries to guess the answer for us. And this is why it's critically important that we think about using generative AI like a CPU, where we give it information and we give it instructions. So what happens when we give it the information? This is what we want to be doing. This is a prompt that is doing the right thing, which is we are giving it information and instructions together. We're giving it the information that it needs to perform the task. Now we copy and paste from the website of USA BMX where they track all this stuff. We copy and paste the information about who won and how many points they had. We copy it into the prompt. We say, here's the information. And now we say, who was the 2023 9 Intermediate BMX state champion? And now it gets the answer right. James White. So you see how when we go and we use it like internet search where we don't give it information, what we're basically hoping for is random generation of the right answer. Now this can be a really good thing. And if we're trying to brainstorm all kinds of things, it can work out for common facts that are really well known, but lots of things it doesn't work for. And so we counteract that by giving it the information like we're doing right here, and then giving it the instructions to perform with that information. Now, I want to bring us back to retrieval augmented generation. And what is retrieval augmented generation? Well, let's look at an interaction with GPT-4 and see some retrieval augmented generation at work. So I'm going to go in and I'm going to say, when is the next practice at Music City BMX? And what you'll see is it says the next practice at Music City BMX are scheduled for June 20th and June 25th, which at the time that I ran this was correct. From 6 to 8 p.m., that is correct. Now, notice up above it, it says searched for sites. That's really important because this is the retrieval piece taking place. And if we click on that, it expands. Now it may have changed, the UI may have changed by the time you're watching this, but you'll understand the fundamental concept. So if we click on that, it says next practice schedule, Music City BMX, Nashville, Tennessee, June 2024, bing.com. This is it retrieving search results from Bing.com. And if we go and we run that search on Bing.com, what we see is it pulls back a bunch of websites, and the text of those websites, if we go and look at the first one, has the practice schedule for Music City BMX. So what's happened is it's gone and retrieved, by running a search, the relevant information for Music City BMX next practice. And then what it's done is it has essentially augmented the prompt with that information and then generated the answer. So just to walk you through that again, it ran a search, which was retrieval. It augmented the prompt with the information, which was what you see here. You see, this is not my original prompt, right? Now, I'm simulating the augmentation because I can't see the augmentation because it's behind the scenes. But this is what it looks like, something like this, where it's gone and taken the first set of websites and the contents of those websites and put some of that text into the prompt. And that's the augmentation part, where it's giving it the information it needs. And then the generation part is this thing that we see below, where it says the next practice for Music City BMX is scheduled from June 20th to 24th. So, retrieval augmented generation is, how do we overcome this problem that it doesn't have access to all the information it needs and it might guess and hallucinate? Well, what we do is we go and retrieve relevant information. We then augment or stick it into the prompt. And then we actually give the prompt to the large language model in order to generate the output. And this is RAG. When you hear about RAG, this is what is happening. Now we're going to talk about how we do this. How do we, for one, let the large language model, or how do we know when it needs to go and retrieve additional information and augment? How do we do the augmentation? Does it matter? Does it not matter? Is there a format that we need to do this in? And so we're going to go and look at the common approaches to retrieval and augmentation, and then the generation part is roughly the easiest of the pieces because it's just inserting the prompt, which we already know how to do, and getting output from it. Now that we have a rough idea of how retrieval augmented generation works, let's focus in on the retrieval piece for a minute, because this is an important one and we hear a lot about it. So if you've ever heard of the word embedding, well, you've probably heard it in the context of retrieval augmented generation, and it's helpful to have a sense of how this works. Now, when you are a normal user, you probably don't care about embeddings themselves, but having a fundamental understanding of what's happening behind the scenes is really, really important to you, because it can be helpful in thinking about how you structure your prompts, how you structure your information, but more importantly, for knowing what can go wrong and how complex this topic is. So I want to take you through what embeddings are and how they're used in retrieval. All right, so let's get started. So let's take an example and let's try to understand, what does that mean to have an embedding? So what I did is I went into ChatGPT and I just thought I'd get its help going in talking about this topic, because I think it's kind of fun to get it to explain the concepts behind itself. So I said, show me an example of what the embedding might look like for who is the Tennessee 9 Intermediate BMX state champion. So we're going to turn this into embeddings. So what does that mean? And I say, explain things to a professional that doesn't necessarily have an AI background or a math background. So basically I'm using the audience persona to make this more interesting and more approachable. So what is an embedding? So let's look at ChatGPT's definition, or GPT-4o's definition. An embedding is a way to convert text into numerical vectors, basically a sequence of numbers. So we're going to take text on one side and we're going to get a sequence of numbers on the other side. And the sequence of numbers are going to represent the text in a format that a machine model can understand. So the idea is these models take in text, but they have to convert it into numbers that they understand. And that process, that embedding process, is that conversion process from the text to the numbers that these models understand. These vectors, meaning these sequences of numbers, capture the semantic meaning of the text, allowing similar text to have similar embeddings. Now this is a really, really critical part for retrieval. So I want to walk through this and talk about this for a minute. The idea is we're going to take the text, we're going to convert it into vectors, which are sequences of numbers, basically a series of numbers. And we want to have the property that if we convert two chunks of text into numbers, that the numbers that it converts them into are similar if the text is similar, if the ideas in the text are similar. So we want to go further. We want the semantics, meaning the meaning in the message in the text. We want, if we have two similar concepts or ideas, we want the meaning to translate to numbers that are closer together. Now, a really simple way of thinking about this is if we are talking about BMX 9 intermediate state champions and 10 intermediate state champions, those might be really close together, so we want the numbers 1 and 2. But if we then start talking about the governor of Tennessee, well, the governor of Tennessee is pretty far away from that, so maybe that's like 100,000 is the number. So 100,000 is pretty far away from 1, but 9 intermediate state champion and 10 intermediate state champion are 1 and 2, so they're really close together. You see? So the idea is to convert it into numbers that have the property that they're close together. Really, really important. Really complex topic of how to do this. And we're not going to go into how this actually works. We're going to talk about how it gets used and then how this impacts you from a prompt engineering perspective. All right. What's the first step? Well, the first step is you're going to do what's called tokenization, meaning you're probably giving it a full prompt, a sentence like who is the 9 intermediate or Tennessee 9 intermediate BMX state champion, and it breaks that down into tokens. Whenever you hear about models and being charged in tokens, this is what you're being charged for. Is basically when you break it down into its constituent pieces, they're going to count the number of constituent pieces, and that's what you're going to be charged for. And then when it produces its message as output, those are also tokens. And they're going to charge you for those individual tokens. So a sentence like, who is the Tennessee 9 intermediate BMX state champion, would be broken down. And this is giving us a hypothetical of how it's broken down into tokens. So we would have all these individual words potentially. Now, it turns out there's a tool, and most of these big models have tools associated with them where you can go and sort of understand what is the tokenization. So in this example, I go into OpenAI's tool and I say, who is the Tennessee 9 intermediate BMX state champion? And it says, well, that's an 11 token basically input, and it shows me what the token identities are these numbers. And then I can also go and look at it from the perspective of like, how does it break my sentence down? And it's kind of interesting. This can be useful when you get really advanced in prompt engineering. It can be helpful to know the tokenization of it, because often it can be helpful to know, is that going to cost me more tokens or less? Because when you start thinking about prompt engineering for cost, you want to find things that work that require less tokens, because that means tokens translate into cost. But what we can see here are some interesting things. So who is a token? Space is a token. Not just is, but space is one token. But then if you look at 9, we get Tennessee, and then we get space is a token, and then 9 is a token, and then space intermediate is a token. And so the tokens aren't always what you would expect. And so sometimes it can be helpful to go and look and try to understand. But what we see is it's breaking the sentence apart into its constituent pieces that it's decided are the important parts, and then it's going to turn that into the embedding. So here's the hypothetical again. ChatGPT or GPT-4o is basically giving us an example. I don't think that, as of my knowledge, it cannot convert something into embeddings for you in its embedding format, but it's kind of giving us an example. Maybe it can. I don't think it can, though. I don't think you can prompt it to do this. I don't think they've added that capability. And so what you would get is each of these words would be turned into an embedding or a sequence of numbers, a vector. Now, we're getting short ones. The real ones are going to be big. Like in this example, it's probably like 768 dimensions, meaning that's the number of numbers that are going to be in that vector. So big, big, big sets of things. Now, again, what the model and what these embeddings are trying to do is get words and meanings that are similar to each other closer together. And it becomes a complex topic of what this means, but that's the important concept, is we want to make sure that who is the Tennessee 9 Intermediate State BMX champion and who is the Tennessee State BMX champion are probably close to each other semantically and meaning. So we want them close together in these numbers or embeddings that we're creating. Similarly, who is the Tennessee 9 Intermediate State BMX champion and who is the governor of Tennessee? They're not really close together, so we want those things to be much farther away. So if you're looking for one, we want the numbers representing the governor of Tennessee to be farther away than who is the Tennessee State BMX champion. Even though they're both talking about Tennessee, so they might be closer together than something else that's not talking about Tennessee. So we want to be able to go and find things that are similar in meaning. Now that's the key. It's similar in meaning. And that's a tricky thing to do. But this is sort of intuitively what's happening, is it's trying to represent these things as numbers where things that have similar semantics or similar meaning are closer together. So we're now going to talk about retrieval with embeddings. What does this mean? Well, retrieval with embeddings is the idea that, and I've went ahead and drawn a picture with ChatGPT. Please refer to the picture and now you can understand RAG. Are you done? I thought that picture was very straightforward and very helpful. And honestly, a lot of the descriptions of RAG that I read and retrieval look like this in terms of complexity, but in reality, it's not that complex to understand well enough at a high level to be able to be effective in thinking and reasoning about it. Now, there's all kinds of details and complexity that look like this level of complexity, but we don't need to go into it in that level of detail. So let's simplify it a little bit. Now, let's imagine we have a document and we want to build a chat bot on top of that document. And when we go and ask questions, we want the chat bot to be able to find the information in that document that answers our question, if it's there. So what we would do is we'd go and upload the document to one of these systems. And then what we're going to do is something called chunking, which I'm going to talk about in a minute. We're going to take each of those chunks, and you can think of a chunk as like a paragraph of text or a sentence. We're going to take each of those chunks and we're going to convert it into an embedding. So this is like the numerical representation of that text. And then we're going to store all those chunks and we're going to associate them with their embeddings. Now, why are we doing this? Well, just like Google goes and crawls a bunch of web pages and then stores those web pages so they can later search them, well, that's what we're doing basically. So we're taking the document and we're breaking it apart into chunks of text. We're storing all those pieces of text separately, but we're really importantly is we're storing an embedding for each of those chunks of text so that later we can go and find chunks of text that are relevant to what we want to do. Now, what we're going to want to do is we're going to want to augment our prompts. So we're going to want to retrieve relevant chunks of text that we've uploaded from that document and then augment our prompt with them. So what we're doing is we're uploading the document, we're breaking it apart into a bunch of chunks of text, either a paragraph or sentence or whatever, and this is configurable. And then we're going to turn those into embeddings and we're going to store it all so that we can search it. That's the rough idea of what we're going to do. Now, what happens then when we go and, hey, we've done this, and now we insert a prompt and we send a prompt off to the system? Well, behind the scenes, what we're going to do is we're going to take the prompt that the user submits and we're going to create an embedding for that prompt. So this is the key part. Remember I told you that we wanted things that had similar meaning to be close together. So we want to create embeddings where the meaning is close together. So we're taking the prompt, what the person entered, their question, sort of the semantics and meaning behind the question, and now we're going to go search for chunks of text that have similar meaning to the question. This is the key step and how embeddings help us, is we now can go and take the embedding for the prompt and use it to search for similar chunks of text. So in this case, we might go and say, well, this chunk of text, interestingly, has similar meaning or semantics to what we see above. When is the next practice for Music City BMX? So we found a chunk of text that, due to the embedding being close to the other embedding, the embedding of our prompt, we say, well, this is a relevant piece of information or a relevant chunk of text, so we're going to include it and insert it into the prompt. And then what we get is we take the prompt, we put the relevant information into it, and this happens all automatically. That's the key. So it goes and looks through the document, and it uses the embedding of your prompt to find chunks of text from the document that look like they are semantically similar because they're close together and the numbers are similar. And then it takes those chunks of text and it puts them into your prompt. And so the end result is you get a prompt like this, and then this behind the scenes is what it actually submits and generates with. Now, if we just go back to this, what's happened is they've taken chunks of text from the document that appeared relevant and they've dumped them into the prompt, and now we go and generate. And in this case, we see that we get the right answer if we do this. We've gone and augmented the prompt with the right information that it needs to generate the answer. So this is what is so critical about embeddings, is that they solve the hard problem of how do I find chunks or text in that document to put into the prompt that will help the model answer the question. And we've talked so many times about how we fight hallucination by giving the model the information, giving the CPU the data to work with. That's what we want to do with these generative AI models, but how do we find the right data? That's the problem that this is solving for. How do I go and automatically find the right information to put into the model? Because what would be the alternative? Well, the alternative is the human being goes and takes all the information from the document and dumps it into the prompt, and that's expensive. That turns into a lot of tokens. Now, we can solve problems that way, and often we want to do things like that, right? If we want a comprehensive answer, we might want to go dump the whole document into the prompt, pay for all those tokens. But in many cases, we don't want to do that. We want to be more efficient. So we want to go find just the relevant chunks of text. Now, we can have the human do that, but by the time the human does it, they've already answered their own question. So instead, what we do is we have it done automatically behind the scenes. We find the relevant pieces of information, put them into the prompt, and then run them. And now we've got retrieval and augmentation working together to help us answer questions and help fight hallucination. So we just go retrieve a bunch of information and put it into the prompt, augment the prompt with all this information, and we're done, right? And unfortunately, it's not that easy. We have to think very carefully about the prompt engineering around that augmentation process, because if we get it wrong, bad things will happen. And so I'm going to give you an example of this. So I've gone and I've done a lot of manual retrieval augmented generation where I'm going and I'm augmenting the prompt with arbitrary information just manually through copy and paste. So let's go back to this original example. Who was the 2023 Tennessee 9 Intermediate BMX State Champion? Well, we could go and we could let the tool try to answer the question and hallucinate again, but let's see what happens when we control the retrieval. We go and choose what information goes into the prompt and augment it with that information. And let's see what happens when we put garbage information in, information that is not relevant to answering the question or performing the task. So I'm going to copy just a bunch of random stuff out of my LinkedIn feed with all the formatting and everything, because we've done a bunch of examples where I've said, look, formatting doesn't matter, and it doesn't matter, but the quality of the information and what's in there does matter, and we'll see that in a second, and how we present it really matters. And now I'm going to copy and paste that into the prompt. So I'm going to replace the original information, which was who actually won and the standings. And now what I'm going to do is I'm going to replace it with this garbage information that I just copied and pasted out of my LinkedIn page, where I'm just put a bunch of random stuff in here, and I copy and paste it into the prompt. And then I give it the instruction, who was the Tennessee 9 Intermediate BMX State Champion? So I have done retrieval augmented generation. I've just augmented the prompt with the wrong information. So what happens when we do this? It comes back and it says the Tennessee 9 Intermediate BMX State Champion for 2023 was Jackson Klein. It's now hallucinated a totally new name, even though I gave it the information. And so we think, oh, well, if we go and do retrieval augmented generation, we're done, right? No, it's not enough. Because if we get the wrong information in there, or the information is not good enough, or it's off topic, or it's subtly wrong in some way, then what we're doing is we're feeding in the wrong information, and we're going to end up with bad output just like we had before. And in this case, if I get all the information wrong, there's not the information that is needed to answer the question. What it can end up doing is filling in the answer with hallucination. So what we're seeing is if there's a disconnect between the information and what it needs to do, it will end up hallucinating. Now, why might there be this disconnect? Well, we might have retrieved the wrong information. And there's a gazillion reasons why we could have retrieved the wrong information. But we also might have presented the information. When we augmented the prompt, we may have done that presentation of the information subtly incorrect. And I'm going to give you an example of why the augmentation, the prompt engineering and the augmentation is critically important and something that we have to think about. I'm going to go back and I'm going to recreate this prompt. Potentially relevant information, but I'm going to do some important, critically important things. And I want to show you what I'm going to do. The first thing is I'm going to take that information that I'm giving it and I'm going to number it. Now, what I've numbered it with is I've just basically given all that original information. There's no meaning to the numbers. It's roughly line numbers. I'm just giving statements with numbering next to it. Now, numbering is important because when we give numbers to things, then we can ask it to refer to numbers. So if I give it some information and I say, here's a numbered list of facts, I can now later say, go and refer to the number of the fact that supports your answer. And that's what I'm going to do in a second. I then go and I give it the instructions. Who was the Tennessee 9 Intermediate BMX State Champion? And I say, output your answer in the following format. And I'm using the template pattern. And I say, champion, insert name. And then I say, insert line numbers of supporting evidence. So I'm telling it, it has to refer back to the facts I gave it and the line numbers of the facts that I gave it. I'm giving it something in the information to reference in its answer. And I'm saying, you're going to give me the answer, and then you're going to tell me the line numbers that support your answer. And so this is doing something, this is creating some consistency. We're trying to create consistency or self-consistency, meaning there's a reference, an identifier in the original prompt, in the information that we're giving it, that we want it to reference in the output, and we want to make sure it's consistent, that its reference that it goes back to actually exists and makes sense. Really powerful way to start improving the quality of the output and making it fact checkable. In this case, something magical happens because when we put that in and we say insert line numbers of supporting evidence and we run it, now it says champion Aiden Coleman, which it hallucinates, but then beneath it, it says no specific supporting evidence found in provided information. So what's happened is we've told it to do something that it is unable to do because there is no supporting evidence. So although it went and hallucinated, then it has to go through and find supporting evidence for that hallucination, and it can't do it, and it's telling us that. Now, had it gone and put some random line numbers in there, we could go and look and see if they are, but many of these foundation models are smart enough to recognize that based on where it is, there's nothing that's supporting it. That we've asked it to perform a task that it's incapable of performing, which in this case is finding supporting evidence for this random person being the champion, and that evidence doesn't exist, so it's saying, hey, it's not there. This is just a simple way of highlighting the importance of the prompt engineering in the augmentation. Yes, the retrieval is critically important. Yes, finding the right information is important if we want to have a hope of answering the question. But the augmentation process, the prompt engineering that goes in there is really, really important. And we can go and control the prompt engineering of the prompt in a way that can account for what may be happening behind the scenes. So we may not be able to control the retrieval as normal users of the system, but we can control our prompt engineering in the prompt in a way that can probably help us tap into and make sure that if something is retrieved that is incorrect, that is spotted, or if there's nothing retrieved that's helpful, that's spotted, and that's all surfaced in our prompt. Retrieval seems a bit like magic. We put these special embeddings in, we go and retrieve the similar text to the prompt, we just find all these chunks, put them into the prompt, and we're done, right? It seems so simple. If only that were the case. Unfortunately, we're going to see that it's not quite so simple. And this is where RAG, although it's phenomenal, requires a vast amount of work and thought and some effort to get it right. Now, there's all kinds of techniques that are used to get RAG right. And I'm not going to go into the depth of all the different techniques, but I want to give you just a sense of the challenges that we begin to face with RAG. And one of the basic ones is the chunk. What is the chunk? Is the chunk a paragraph? Is it an entire page of the document? Is it a sentence? Is it a few words? Is it a table? What the heck is a chunk? And this is a critical, painful problem to determine. Now, it doesn't have to be, but it can be. Now, why would this matter? Well, I want you to think about it. What is the meaning of this page of text? Take a moment, read it, and tell me what the meaning of this page of text is. Now, read one individual paragraph in this page, and does it have the same meaning? Well, let's look at an example. The whole thing is all about the computer science department at Vanderbilt and the curriculum and other requirements for undergraduate students. Now let's read an individual paragraph. The computer science major provides an excellent background for medical students, and the flexibility provided by its many open electives allow students to prepare for medical school while also earning a degree in computer science with a normal load in 4 years. Interested students should discuss their plans with the computer science advisor. Well, the meaning of that paragraph is probably very different in semantics, in distance, in representation than the meaning of the overall document. The overall document is really about computer science in the computer science department. The meaning of that paragraph is about computer science for medical students. And so depending on what our chunks are, our beddings are going to be different. And if we're now a medical student looking for information, we might not find this if we're chunking at the page level. On the other hand, if we are chunking at a smaller level, we may miss something, and that becomes the issue. So let's take a look at what we might miss if we chunk at a smaller level. So it might seem like, okay, well, it's no problem. We just go and chunk at a smaller level. Well, if we go and chunk at a smaller level, I want you to take you to this bottom part where it has course requirements. Let's imagine we go and split course requirements, and we end up splitting that into 2 different chunks. Now, there's different ways of trying to make these things overlap, all kinds of stuff to try to solve this problem. But we're not going to look at those specifically in detail, but let's just look at this problem of, let's assume that we've taken this last bit of the page, the curriculum requirements, and we've built that, and we've now chunked it into 2 chunks. So this was the curriculum requirements, and we've now split it into 2 chunks. What's the issue that we're going to run into here? Well, one issue is if I am a computer science student and I go search for chunks that are relevant to computer science students, I may or may not find those bottom requirements, because the bottom requirements down there, when you take away the sentence that says the BS in computer science requires a minimum of 120 hours distributed as follows, that provides context for the information that comes next. If you take that away and you strip it away, now I'm running into the problem that my computer science requirements are no longer scoped to computer science, and instead I see I have a bunch of requirements that include computer science classes, but it doesn't tell me what major they're for. And there's other majors on campus that have requirements that include computer science classes. Now I can't tell the difference between the two because I've just got lots and lots of chunks that tell me about computer science requirements, and I might not get the chunk I want, or even worse, I get the wrong chunk. And because we've removed the top part that gives context to what we've got, now we've got a problem. Like, how are we going to know that we got the right chunk? And how is the LLM now going to know that what that information means? Or what happens if it gets a whole bunch of chunks that say curriculum requirements, none of them scoped with that header? Does it assume that all of them are relevant? Does it assume that in one of them is relevant and just picks randomly some subset of them? And you see how a chunk can now become a problem if the chunk is not the right chunk. Like if it's not semantically whole for the question that we need to answer, we're going to be in trouble. Okay, what else can go wrong with the chunking? Well, let's think about the presentation of the chunks. Let's say we split that apart, but we go and we get lucky and we get both those chunks. Well, what happens if we present them out of order? We say, you know what, the requirements seem like they're more relevant, so we're going to put that chunk first, and then we're going to put curriculum requirements. And then we're going to lay this all out as text into the prompt. Well, if you're the LLM, now this looks a little tricky. Are what you see, what the thing you're seeing above, is that the set of requirements, and then this is describing the start of a new set of requirements that aren't provided? Or are they the same thing? And if they're the same thing, then maybe I need to merge them together. And you see now it's the complexity that happens. It's like this simple concept of like reading the document. Well, you can imagine if somebody went and just took a paper cutter and they sliced up your document into all these strips of paper, and then they scattered them across the floor, and then you asked a question and they're like, yo, no problem. And they pull out a couple random pieces of paper and they hand them to you. And those strips of paper have a chunk of text on it, and you're reading them and you're like, do these go together? And what order do they go in? And these are all sort of augmentation aspects and prompt engineering aspects that really, really matter, right? Because if those things are given to you without the appropriate context or incomplete, you get half the requirements, but you feel forced to answer the question. You may give an incomplete answer that looks like a right answer. So many things can go wrong. Another simple thing is what happens and how you present the information in the prompt. So if you go and you show the information and you say relevant information, you almost are implying that the information needed to answer the question is there. So imagine, again, we've sliced up that document into a bunch of strips of paper. We've dumped them on the floor. You go and you're like, I have this question. And the retrieval person goes and searches through this stack of paper. He pulls out all these slips of paper with different chunks of text, and he shoves them in your face. And he says, here, the answer is there. Here's the relevant information. Go help yourself and answer the question. You're like, man, it's kind of weird, but I think the relevant information is here. So I'll do my best to answer the question using what's put here. Because he told me this is the relevant information, so it must be right, so I'm going to answer the question, right? But what if the information that you're given is not actually relevant? Like, what is it if it's garbage? And the fact that he told you that it was relevant now is a problem. What if he told you, well, I searched through the stack of papers and I found a bunch of slips of paper, these chunks of text. They might be relevant to you. Why don't you look through them and see if anything is valuable to you? And you see how that slight change in how we word and present it totally, influences the way that we're going to answer this question. So there's so many subtle details, everything down to, what is a chunk of text? When we go and retrieve, do we put them back together? And if so, how many of them do we stitch back together? Do we stitch them back together in order? Do we reorder the chunks of text after they've been stitched together in some way? How do we word what we are doing when we present it? Like, all of these things can have an impact on what happens. And we have to think very carefully and thoughtfully about this from a prompt engineering perspective. But as a user of the system, we want to be cognizant of this and try to design prompts in such a way that we don't end up having bad things happen because these retrieval augmented generation systems are imperfect and may not find the answer, that we need, may not find the chunks that we need, may not present them in the right order, may not merge them together appropriately, may not do all kinds of things. And this is what makes it challenging. Thank you for going on this journey in advanced prompt engineering with me. As you go forward, make sure and remember all the key techniques that we use throughout this course. So I want to just quickly review some of the most important ones. 1, in-context learning. Yes, instructions can be really powerful ways of telling the large language model what we want, but sometimes just providing examples can be the most powerful way that we can get it to refine its behavior and pull out that behavior that we're really looking for, those nuances. For example, when we're writing, and it's really hard to write the instructions for what we want. In-context learning can be a really, really powerful tool when we're going and building prompts. And in fact, most prompts can really benefit from in-context learning and providing examples of what we want. Second one, preference-driven refinement. We don't have to have all of the examples up front. We can actually iteratively use the prompts to build the examples that we later bring back into the prompts for in-context learning. So remember, you don't have to start off with a data set. You don't have to start off with all the examples that you've built by hand. You can actually do it interactively. And you can teach and improve the large language model through your prompts with in-context learning by having it generate things, find the parts of the output that you like, bring them back in as positive examples or negative examples to instruct it what you're looking for. Second, I want you to really remember that these models are powerful or general tools for machine learning and AI. And you can go and do classical, machine learning and AI problems with these things like classification, sentiment analysis. So make sure and know that and be aware of it and tap into it. And then when you need to teach it something new, go back again to in-context learning. Third, output formatting. Output formatting is one of the secret, tools in an advanced prompt engineer's tool belt. And so many people just go and say, this is what I want, but they don't say, this is the format that I want it in. And the format, particularly when we start using placeholders, can be a rich way and a very concise way to help, instruct the model how to produce exactly what we're looking for. And then use your knowledge of retrieval augmented generation to help, build prompts that have safety built into them, that have references back to information that was given to them in the prompt or maybe was retrieved from results, that have citations, all kinds of other things that make the output more fact checkable and something that helps us to ensure that we can trust the results that we're getting. So I really hope that you've enjoyed this course, and I hope you'll continue learning more and more about prompt engineering and how to tap into these powerful capabilities in generative AI models.